So hey everyone, Jane Angelique Nuevaespaña here, and I'm about to discuss with you the twins paradox. So early in the study of special relativity, students learn about the phenomenon of time dilation, that moving clocks run slow. So those who have properly appreciated the fact that all motion is relative and who have properly appreciated that clocks measure the passage of physical time ought necessarily to experience some mental discomfort at this result. So after all, when two observers pass each other, the prediction is that both will find the other's clocks to run slower than their own. So this might well seem to be impossible on its face and therefore to invalidate the entire theory. Nevertheless, a detailed analysis that properly takes into account two other equally peculiar relativistic effects, which is called the Lorentz factors, shows that one can build a perfectly sensible relativistic world in which all observers agree on the only things that they might agree on, including the details of local events and the temporal order of causal consequences. And when we say paradox, it is about a statement or proposition that seems self-contradictory or absurd in reality. It expresses a possible truth. And when we talk about the twins paradox, it is about imagining and analyzing one of the two identical sisters, which is the twin B, and of course, the other one is the twin A. So twin B went flying off into space at a more or less the speed of light. And according to relativity, time runs more slowly on her spacecraft than it does on Earth. And both twins agreed that twin B will be younger than twin A. The one who journeys to the space will be the younger one than the one left on Earth. So both twins agreed, and do you think that they're right about their assumption? Well, let's see about that. The so-called twin paradox is easily resolved by noting that there is a physically meaningful distinction between the experiences of the two twins during the trip. So the earthbound twin remains in a single constant velocity reference frame the entire time, and while the traveling twin must accelerate to turn around and come home. So the acceleration causes the traveling twin to change from one constant velocity reference frame to another and produces effects that can be measured locally by the traveling twin in the form of inertial forces that can knock things over, compress springs, and generally endow objects with weight. So as a result of the fact that their experiences are different. The simple explanation about this is because the notion of simultaneous times rotates that twin A is accounting how time passes in parts of the universe far away from twin B will have gaps on it, when in reality, it wouldn't have gaps because twin A couldn't change direction in an instant. So twin A should have to fire her rocket, start heading home, and during that acceleration, her notion time would have very quickly rotated through the missing gap, which results to allowing her to properly account for the missing time. And oh, by the way, the time rotations mentioned are called the Lorentz transformations. It is said to be the way that working physicists think about special relativity and things like time dilation and many more that we are still so far ahead of us to further understand. So let us absorb in our minds that when we are moving or move things, time really does pass slowly. That explains this one. So thank you, and I hope you followed everything I said. And let's keep on wondering interesting things though. Goodbye!